Hello, happy people. This is Mr. Wilcox coming to you from my kitchen table. This video is for my pre-calc class. So in pre-calc, we've been talking about limits. In fact, this whole chapter has been about limits. And what that's leading to is our next chapter and chapter after that to finish out the year are going to be about derivatives. And so today we are going to start learning what that is by using the limit to find the slope of a tangent line. So here's what a tangent line is and a derivative. So I'm going to pause here for a second so you can write these things in your notebook. It may be helpful to sketch this picture. When you're ready, just hit play again. All right, so hopefully you remember from your geometry days that a tangent line is any line that touches a curve or a shape only once. You use these a lot when you were talking about circles. So you talked about a line that touched a circle only once. Any curve that is graphed, we can have tangent lines for. So for example, this curve down here, a tangent line would be this green line because it touches the red only once. And what a derivative is any function that gives us the slope of that tangent line at any point. So we're going to use the limit definition today. And because that's in the limit chapter. So last thing we are going to finish this chapter with is finding the slopes of tangent line and finding the equations of tangent lines using limits. So to do that, here is the formula we are going to use today to find the slope. I am again going to pause right here so you guys can write this in your notebook. So just pause the video and hit play when you are ready. So to find the slope of a tangent line, we are going to use this limit formula. When you look at other videos or other websites, they might give you a limit as x goes to h. And instead of a c, they might have an x plus h. It's the same thing. You're just given different pieces of information. Since we're just starting this, we're going to use the easier one, which is if we're given a point c f of c, so our x and our y give us our c and f of c, and an equation, then we can find the slope of the tangent line using this formula. This one's just slightly easier to start off with, but they are the same definition. So we are going to use this formula today. We're going to take the limit as x goes to c. We're going to plug in our f of x and our y, and on the bottom we're going to take x minus our x value of our point. So here are the steps we are going to use. So again, I'm going to pause so you can pause the video, write them down, and hit play again. All right, these steps will make more sense when we do an example, but we're just going to go through them right now. So the first thing we're going to do is, given the point we have and the expression, we are going to fill in the given expression and point into our limit formula that we just wrote down. And then we are going to find the limit by simplifying. And then if we need to, we can factor and cancel. And then we can do our substitution to solve. So those steps will make more sense when we do an example. So here is our first example. We're going to find the tangent line that goes to the point 1, 4 for the function f of x equals x squared minus 5x plus 8. All right, so first of all, every point they give us, remember, is our c and our f of c. So to find our slope, we're going to take the limit as x approaches our c, so in this case 1, and then we are going to take our f of x, so x squared minus 5x plus 8, and we're going to subtract away our f of c, which in this case is 4, and we're going to put that over x minus our c, which is 1. So you can see if we plugged in our 1, we would get a a zero numerator, so we do have some simplifying and some factoring to do. So if we simplify that, we're going to get the limit as x goes to 1 of x squared minus 5x plus 4 over x minus 1. So to try to simplify that so we don't have a zero denominator, we can factor. So what multiplies to get positive 4 and adds to get negative 5? Well, that's x minus 1 times x minus 4. So our x minus 1s then cancel out. And if we plug in our number for x, we're taking the limit to 1. So I'm going to plug in 1. And so our slope is 1 minus 4, or negative 3. So that means the slope of the line that touches the function at 1, 4 has a slope of negative 3. All right, so here's our second example. We're going to find the slope of the tangent line through the point 212 that is tangent to x squared plus 14x minus 20. So again, what we're going to do is we're going to take the limit as x approaches our c. In this case, our c is 2. And on top, we're going to have our f of x, so our x squared plus 14x minus 20. And then we're going to subtract away our f of c. In this case, that is 12. And put it over x minus our c, so x minus 2. So if we simplify our top, we're left with the limit of x goes to 2 of x squared plus 14x minus 32 all over x minus 2. So what multiplies to get negative 32 and adds to get 14? Well, that's going to be x minus 2 times x plus 16. We have an x minus 2 on bottom. So our x minus 2s are going to cancel out, leaving us just with x plus 16. So I'm taking the limit to 2. So I'm going to plug in 2 for x. And so my slope is 18. So that's another example of finding a slope of a tangent line to a parabola. Our next example is going to use a different kind of function. We're going to use a radical function. All right, like I said, our last example, we're going to use a radical function to find out what our slope of our tangent line is. So we're going to use the same process. We're going to take the limit as x goes to our c, in this case 7, of our f of x, which is the square root of x plus 2, minus our f of c, which is 3, and put it over x minus our 7. So remember when we had a radical and we couldn't do anything to have anything cancel out, we had to multiply by the conjugate. So I'm going to multiply the top and bottom by the square root of x plus 2 plus 3, because I have the square root of x plus 2 minus 3 on top. So I'm going to multiply that by the square root of x plus 2 plus 3. And then I have to do the same on the bottom with our x minus 7. And the reason I do that is because it will cancel out our square roots on top. So if I do that, the square root of x plus 2 times the square root of x plus 2, if I take the square root of anything and I multiply by itself, remember that's squaring, so I'll just get the radicand, which is x plus 2. And then if I have negative 3 square roots of x plus 2 plus 3 square roots of x plus 2, those cancel out. and then I have negative 3 plus 3, which is minus 9. And I still have x minus 7 times the square root of x plus 2 minus 3 on top. I'm sorry, on bottom. So x plus 2 minus 9 is x minus 7. And I still have an x minus 7 and the square root of x plus 2 minus 3. So my x minus 7s cancel out. So then I can plug in my x value, which is 7. So I'll get the square root of 7 plus 2 minus 3 on the bottom. Square root of 7 plus 2 is 9. 9 square root of 9 is 3. So I will get, this is a plus 3. I will get 1 over 3 plus 3, which is 1/6. All right, so a little bit longer process to multiply by the conjugate, but you have done it before, so hopefully it's not that much harder. So that is using the definition of a limit for derivative to find the slope of a tangent line. I hope you are all happy. I hope you're all healthy, and I hope you all have a great day.